Today we will discuss some more problems from the first chapter, vector algebra. The first question is, compute the divergence of the function v equal to r cap by r square in Cartesian coordinates. Okay, so this is the function is r cap by r square. We have to calculate the divergence, that is del dot v, in Cartesian coordinate system. See, we have already seen this particular function, isn't it? And we have calculated the divergence in spherical polar coordinates when we have discussed the Dirac delta function, isn't it? So we have to do the same thing in Cartesian coordinates. So this v can be written as r cap by r square can be written as r bar divided by r cube, where this denominator is the modulus. Okay, this is the unit vector r cap and this is the vector r. Okay, the position vector r. Now this can be, okay, can calculate the del dot v as dou by dou x of x by r cube plus dou by dou y of y by r cube plus dou by dou z of z by r cube, isn't it? Because this r bar is x cap plus y cap plus z cap. So you have to take each component separately when you take the dot product. Okay. So this can be written as dou by dou x of x into what is r? R is the modulus, that is square root of x square plus y square plus z square, isn't it? So this r cube can be, the denominator is this one, so it can be written as x square plus y square plus z square raised to minus 3 by 2, isn't it? Take this one to the numerator, and r is the square root of, that is x square plus y square raised plus z square raised to half. Then raised to 3 is there, so minus 3 by 2. Okay. Then plus the same thing is for the y and z part, that is dou by dou y of y into x square plus y square plus z square raised to minus 3 by 2 plus for the third one it is dou by dou z of z into x square plus y square x square plus y square plus z square raised to minus 3 by 2. Okay. Okay, now next step is we have to do the or take the derivative. First one, it is equal to, that is del dot v is equal to dou by dou x of x by r cube, this one. Okay, so this one will be first, suppose x is there. Okay, so this is the first one, this second one. Okay, so this can be written as this is equal to x square plus y square plus z square raised to minus 3 by 2, then plus x into derivative of this one, x into minus 3 by 2 into x square plus y square plus z square raised to minus 5 by 2. Isn't it? Minus 3 by 2 minus 1, that is a minus 5 by 2. Then into derivative of this one, that is a 2x. Okay, plus what about the second one? Dou by dou y of this one, Again the same thing, isn't it? X square plus y square plus z square raised to minus 3 by 2 plus y into minus 3 by 2 into x square plus y square plus z square raised to minus 5 by 2 into 2y plus third one is again the same thing, x square plus y square plus z square raised to minus 3 by 2 plus z into minus 3 by 2 into x square plus y square plus z square raised to minus 5 by 2 into 2z. Okay. Now see the first one is, what about the first one? This is r, isn't it? So this is x square plus y square plus z square raised to half is the r, isn't it? So this is r raised to minus 3, isn't it? R is the magnitude of the position vector, that is equal to square root of x square plus y square plus z square. So that raised to minus 3. So you can write it as r raised to minus 3, isn't it? And again we can write it in single line. This is r raised to minus 3, this is r raised to minus 3, this is r raised to minus 3. So that is equal to 3r raised to minus 3, isn't it? 3r raised to minus 3. Now what about the next one? This is a minus 3 by 2 is there, 2 is there. So 2 cancels. This one 2 cancels. This one also, here also 2 cancels. Okay. So what is remaining is that x square plus y square plus z square raised to minus 5 by 2 is common here. Okay. So you can write it as x square plus y square plus z square raised to minus 5 by 2 is common. Then what is remaining is 2 cancels, then it is minus 3x square, isn't it? Into minus 3x square plus what about the second one? Minus 3y square, 3y square, and the last one we have minus 3z square. Okay. Again this is equal to 3r raised to minus 3, then plus this is there r raised to, this square raised to half is r. So this is r raised to minus 5, isn't it? Now minus 3 is common, so you can take that outside. So this can be written as minus 3 r raised to minus 5. Minus 3 is taken outside. So what is inside? X square plus y square plus z square. Okay, that is equal to again r square. So this is equal to 3r raised to minus 3 minus 3r raised to again minus 3, isn't it? So the value is equal to 0. Okay. So the divergence of the function v, the vector v in this case will be equal to 0. So we have encountered the same thing in the case of Dirac delta function, and we have seen that, see, there is one paradox there, isn't it? By using the theorem, that is the divergence theorem, we can show that this is not actually equal to 0. We have already discussed that. Okay. So that is, so we have obtained that in terms of the Cartesian coordinate system. This value is equal to 0. Now the next question. Next question is, let R be the separation vector R. Let R be the separation vector from a fixed point x dash, y dash, z dash, x dash, y dash, z dash to a point x, y, z. Okay, so x dash, y dash, z dash to x, y, z. So that vector is called a separation vector. Okay, separation vector is represented like this. Okay, whereas the position vector is represented like this. Okay, where the position vector is the distance from the origin to that particular point. Here we have another point x dash, y dash, z dash to x, y, z. So that reference point is not the origin. So in that case we write it as the separation vector. Okay, so you have a separation vector and let r be its length. Okay, not the bar is there, r be its length, that is the magnitude. Okay, so you have the separation vector and the magnitude, and the question is show that del of r square, del of r square is equal to 2r bar. Okay, so this is a vector and this is the magnitude. Okay, so del of r square equal to 2 into r bar. That is the first question. So you have two parts here. So what is r then? So you have to find r square. Okay, so what is r? R is equal to, the magnitude is equal to x minus x dash into x cap plus y minus y dash into y cap plus z minus z dash into z cap. So this is the separation vector r. Okay, now so this is r. Okay, now what is r then? The magnitude is equal to square root of x minus x dash the whole square plus y minus y dash the whole square plus z minus z dash the whole square. Okay, so this is the magnitude of the vector, and what is required here is r square. So r square is equal to, simply you can get rid of the square root, isn't it? X minus x dash the whole square plus y minus y dash the whole square plus z minus z dash the whole square. Okay, now you take del of r square, del of, sorry, r square, r. Okay, so that is equal to, what is it? Del of, so this will be del of any function is equal to, suppose f is a function, what is del of? Dou f by dou x into x cap plus dou f by dou y into y cap plus dou f by dou z into z cap, isn't it? So this is a function. So del of r square is a dou by dou x of f. The function is this one. Okay, so you can write it as x minus x dash the whole square plus y minus y dash the whole square plus z minus z dash the whole square. Okay, plus dou by dou y of, okay, so here you have an x cap is there, this is the gradient x cap, plus the same thing is repeated for the y and z direction. So dou by dou y of this term, whatever, into y cap plus dou by dou z of the function into z cap, isn't it? The same function is repeated inside. Okay, so that is equal to, what is the first one? This is equal to 2 into x, isn't it? 2 into x, then into x cap plus second one, same thing, you will be repeating the same thing inside. So dou by dou y means it is a 2 into y. Okay, you are writing this one here and derivative with respect to y, so that will be equal to 2 y into y cap, and do the same thing for the z component. Okay, dou by dou z of this type into z cap. So that is equal to plus 2z into z cap. Okay, so that is equal to 2 into x cap plus y cap plus z cap. Okay, what is that? So that value will be equal to, sorry. So this is equal to 2 into x minus x dash, isn't it? Into that, this term is there, x cap, plus 2 into y minus y dash into y cap, plus 2 into z minus z dash into z cap, isn't it? 2 into derivative of this one, 2 into x minus x cap into x cap plus 2 into y minus y cap plus 2 into z minus z dash into z cap. Okay, so this is 2 into all these type, x minus x dash into x cap plus y minus y dash into y cap plus z minus z dash into z cap. So that is equal to the vector, the separation vector r. Okay, so del of r square is obtained as 2 into r bar. Okay, the separation vector. So that is the first part. Now the second part is show that, so this is the first one, and the second part is show that del of 1 by r, 1 by r is equal to minus r cap by r square. Okay, this is the second one. Del of 1 by r is equal to minus r cap by r square. Okay, now what is r? R is equal to x minus x dash the whole square plus y minus y dash the whole square plus z minus z dash the whole square. Okay, raised to half. So I am writing this one like raised to half. Okay, so this is del of 1 by r. 1 by r means that is equal to this one raised to minus r, isn't it? So what is del of 1 by r then? We can write that r is equal to, so similar to this case, the function is there. So we can write it as, so 1 by r is this one raised to minus r, isn't it? So this one will be, the equation will be dou by dou x of 1 by r, that is equal to x minus x dash the whole square plus y minus y dash the whole square plus z minus z dash the whole square raised to minus half. Okay, plus dou by, okay, sorry, into x cap is there. Plus dou by of the term into y cap plus dou by dou z of that term into z cap. Okay, so the same thing is there. The same bracket will be repeating at these two positions. Okay, now what will be the value then? This is equal to, so this is taken as x. Okay, so x raised to minus half. So this will be minus half into this term, that is x minus x dash the whole square plus y minus y dash the whole square plus z minus z dash the whole square raised to minus 1 by 2 minus 1. Okay, minus 3 by 2 into 2x minus x dash. 2x minus x dash into x cap, isn't it? This x cap is there. Then plus the second term will be the same thing. What about the second term? Again you have minus half into the term that is inside, then raised to minus 3 by 2 into 2 y minus y dash into y cap. Okay. Then what about the third term? Minus half into that term inside raised to minus 3 by 2. Then with respect to z, then 2 z minus z dash. Z dash into z cap. Okay. Now, how will you combine this? That is minus half into this one, x minus x dash the whole square plus y minus y dash the whole square plus z minus z dash the whole square raised to minus 3 by 2. So that will be raised to half is the magnitude, isn't it? So that will be r raised to minus 3, isn't it? So that is r raised to minus 3 minus half into this one, okay, raised to minus 3. Then okay, into, okay, 2 is there, 2 x minus x dash into x cap plus, okay, that is minus, again we can put the value is equal to minus half into r raised to minus 3 into 2 into y minus y dash into y cap minus half into r raised to minus 3 into 2 into z minus z dash into z cap. Okay. Now 2 cancels. So this is equal to minus r raised to minus 3 into, what is remaining is x minus x dash into x cap plus y minus y dash into y cap plus z minus z dash into z cap. So that is equal to r bar, isn't it? Okay. Now that is equal to, how will you write? That is equal to minus of r bar divided by r cube modulus. Okay. Now this is equal to, so what we have to prove is r cap by r square. And you take this as r into, sorry, you can write it as 1 by r square into r bar by r, isn't it? And what is r bar by r? That is equal to r cap. So this is equal to r cap by r square. Okay. So r cap by r, that is what we have to prove. Okay. Starting with the gradient of del of 1 by r. Del of 1 by r equal to minus r by r square. Okay. So this is the cap. Okay. R cap. So that is the second question. Now the third question is, show that the vector v equal to, sorry, show that the vector v equal to y squared x cap plus 2xy plus z square into y cap plus 2yz z cap. Vector y square x cap plus 2xy plus z square into y cap plus 2yz into z cap is irrotational. Irrotational. Okay. So how will you prove that? In order to prove that a vector is irrotational, so what we have to show is that del cross that vector is equal to 0. Okay. So that is what we call a curlless or an irrotational vector. So we have to prove is del cross v is equal to 0. So how will you do that? It is very simple. Del cross v equal to x cap, y cap, z cap, dou by dou x, dou by dou y, and dou by dou z. Then x is y square, x component is y square, and 2xy plus z square, and then 2yz. Take the determinant. Okay. So evaluate this. You can see that this value is equal to 0. So we can conclude that the given vector is a irrotational one. Okay. So that's all for now. We will see in the next class.